Alright, section 7.2. So chapter 7 talks about systems of equations. And what's a system of equation? It's a system that consists of more than one equation. So a system of equation has multiple equations. We are used to linear equations, which means a system of straight lines, multiple straight lines. Nonlinear means some of those are not straight lines. A solution to a system of equations, if you remember from back in the days, is the value of the variables that satisfy every equation in the system. So when I look at graphically right here, so the definition, a non-linear system of equations is a set of two or more equations. At least one of them is non-linear. Non-linear is not straight line. In this case, what we're looking at right here, the three cases, assume you have a parabola and a line. So the value that satisfies both is really the intersection. This has two solutions. This has one solution. And here we have no solution. So if you recall, if you get a solution, you'll get an x equal and a y equal. If you get no solution, that means when you're solving the algebraic equation, you'll get a contradiction. You'll get like a 5 equals 7. And since we are here, if you have a parabola and a line and you only get one solution, that means that line is tangent. What's a tangent line? A tangent line to a curve. A line is tangent to a curve when it touches but does not cross. So it touches the curve at one point, barely touches it. First set of problems says solve by graphing. We could do that. We know how to graph a line. I'm going to start at -2. That's a point. I'm going to rise 2 down, 1 to the right. Draw my line. And let's go with the purple and blue. Blue for the line. There's the line. I'm going to shift that a bit up, just a bit, 1 unit up. Here we go. And if I go by the parabola, doesn't that go down 2 units? And it opens down, right? Something like this. And how many solutions do you think we're going to have? We're going to have, in this case, solve by graphing. Kind of hard to pinpoint the solution off of a graph. I know the solution is 0, -2. That is, if I replace x by 0, I'll get -2 in both of those equations. I need to know where that point is. That point seems to be at 1, 2. It seems to be at 2, -1, -2, -4. It seems to be at -5. Now, is that true or not depends on how good your graph is. And that's the point. The point is that if I want to look at a graph, it's kind of hard to see how this works. If I look at the next problem, sketch a graph of a parabola shifted down 1, 2, 3, 4 units. The parabola looks like this. And again, a line starts at -1, rise 2 down, 1 to the right. If I connect this with a straight edge, meaning a ruler, again we have another problem. I know this point seems to be the solution. That point right there seems to be 1, -3. Okay, but what do you think this point is? Isn't that point very hard to find? -1, -2. It looks like -3. It looks like 5 or 6. Again, the point here is to show you that graphically this is very hard to do. Can we do it a different way? Of course, that's the rest of the section. When it says solve each system by any method you want, we're going to do everything algebraically. You could graph them, but you're going to do things algebraically. Why is that? Because I don't like guessing what this point is or what this point is. Is this point 2, -5? I'm not certain. And is this point -3, 5? I'm not certain. But if I wanted to be certain, I could know exactly what those are algebraically. Here they said graphically. For example, I could, if I want it, substitute. Take this and substitute it in for that y. That equation, that first equation will become negative 2x minus 1 equal x squared minus 4. That would mean 0 equal x squared plus 2x minus 3. 0 will equal x plus 3 and x minus 1. X would be a negative 3r1. If x equals a negative 3, put a negative 3 right there. That's a 6 minus 1 is 5. I got it right on just, and if I put a negative 1 in, that will be negative 2 minus 1, negative 3. So algebraically, I'm certain. Graphically, I'm guessing. So the rest of the work is algebraic. And we're going to do parabola and line, circle and parabola, ellipse, and I think we do ellipse. I'm not sure. Maybe not. Yep, ellipse and a circle. No biggie. It doesn't matter what it is. You could sketch a rough graph if you want to see it, but you don't have to. How does this work? We're going to always use substitution in these cases. We could use elimination. It doesn't really matter. Do you see that this y is in terms of x? I'm going to put that right there. So that equation is going to become negative 2x plus, instead of y, I'm going to throw in all of this. X squared minus 2x minus 3 equal to negative 6. This is a polynomial. You isolate the name by itself, meaning you get the polynomial on one side, everything else on the other side. And we know everything there is about polynomials. So I know that x equals a 3 or a 1. If x equals a 3, what does y equal? If x equals a 1, what does y equal? You could go to either equation. It doesn't matter where. If I replace x by 3, I could do that here. I could do that here. It makes no difference. Since this is already solved, if I put a 3 there, isn't that 9 minus 6 minus 3? And that will be a 0. And if I put a 1 right there, I'll get 1 minus 2 minus 5, which is a negative 4. There you go. A lot better than graphing and trying to guess where these values are, especially if it's a decimal or a fraction. Here I have two parabolas. It doesn't matter. I need to solve for a variable. I'm going to use substitution. So if I make it a habit of solving for one of those, let's say that one. It doesn't matter which one. If I say here that, you know what, y equals 4 minus x squared, and it doesn't matter which variable you solve for, and plug it in there. Wouldn't that top equation become negative x squared plus y? Well, y is actually 4 minus x squared. That's my substitution. Equals 4x plus 4. And this is negative 2x squared. Or actually, yeah, okay, that's okay. Plus 4 equal 4x plus 4. If I move everything to the right, I'll get 2x squared plus 4x equal to 0. Factor. So I'm getting x to be a 0 or a negative 2. Very good. If x equals 0, what does y equal? If x equals negative 2, what does y equal? It's right there. If I put a 0 in there, I'll get a 4. If I put a negative 2 in there, 4 minus 4 is 0. I could graph this. Not recommended. I suggest you stick with the algebra. That's much more efficient. The graph is good to see how many solutions you have. Here I have a circle and a parabola. Again, I could do a rough sketch. There's no point in doing that, but I could show you really quick. I have a circle. The circle looks like this. In which is, this is 5. I have an upside down parabola. That looks like this. It seems I have 3 solutions. Well, again, the graph is not part of it. The way it works, I need to use substitution. Now, I have a couple of options. I could throw this in there, but then that's going to be squared. That's going to be big. Instead, observe that, you know what? I could solve, since there's an x squared there, I could solve for x squared there. Not that it matters, you can do this any way you want. Wouldn't the top equation be x squared equal 25 minus y squared? And if I take this quantity and put it right there, wouldn't this read y equals 1/2 of 25 minus y squared minus 5? That's what I substituted in. It didn't register. Wouldn't that be 2y equals 25 minus y squared minus 5? If I get everything on the left, again, I want everything to be positive. So wouldn't that mean, do it in 2 steps. Isn't that 2y equals 20 minus y squared? So y squared plus 2y minus 20 equal to 0. And if I want 2 factors of 20, yep, I made a mistake. When I clear the fractions here, you multiply this by 2 and you multiply this by 2. That makes that a 10. That makes this 25 minus 10 is 15. That makes that minus 15. Well, doesn't that make this y plus 5 and y minus 3 equal to 0? So y will equal a negative 5 and y will equal 3. So, if y equals a negative 5, let's see how this plays now. If y equals a negative 5, I have x squared equals 25 minus 25, which is 0. That means x equals 0. So I have that point 0, negative 5. What happened? How come it's not matching? Oh, okay. Well, good, see? That's why, again, graphically is not the way to go. Isn't this a parabola that's cross at negative 5? And that opens up. I did it completely backwards. And if x equal a 3, if y equals a 3, if I put a 3 there, wouldn't that be x squared equal 25 minus 9, which is 16? And if you square root both sides, wouldn't x equal plus or minus 4? So this point is 3, 4, negative 3. This point is 4, 3. This point is negative 4, 3. And this point is 0, negative 5. Algebraically, I can get everything. You don't have to graph any of those. It's good if you know how many solutions you have, but as you saw, if you mess up the graph, you might mess up the problem because you graphed wrong. Algebra matches. You should really stick with the algebra. And let's get the next problems up. I'm looking at a circle and a parabola. Again, they have y equal. You could substitute that in, but that's going to make it x to the 4th, which is a lot of work. I strongly suggest you solve for this x. And you say, look, this right here, this says x squared equal 49 minus y squared, and substitute that right there. That would read y minus 1 over 20 y equal negative 1 over 28 into 49 minus y squared plus 7. I would clear the fractions. That's only me. LCD is 28. Multiply by 28 top and bottom. 28y equals negative 49 minus y squared plus 7 times 8 is 56. 14, 19. Okay, a big numbers, that's okay. That's a negative 49 plus y squared plus 196. 28y equals y squared. And what is that? If I subtract those, that's a positive. Let's see. 16 minus 9 is 7. And 4 minus 8 is 4, 147. And if I get this into standard form, 0 equals y squared minus 28y plus 147. And if you add those, that adds up to 12. So 3 divides this. So if I go on the side, 147 is 3. 3 divides 11 4 times. We have 2 left over. 3 divides 27 9 times. 3 and 4, remember, I want them to add to get me 28. That's not going to work. If you add those, you only get 28. Take a 7 out. Right? That's 3, 7 times 7. So isn't that 21 and 7? There you go. Those add up to give you 28. So this is actually... So some of these problems are longer than others. No biggie. We have plenty of space. So this is really 0 equal y minus 21 into y minus 7. And if you can't get the 7 and 21, you could complete the square or use Pythagorean, whatever. You could complete the square or use quadratic formula. So I'm getting y to be a 21 or a 7. Okay, there they are. If y equal 21, remember, I could go back to this and figure things out. I'll get x squared equal 49 minus 21 squared. What's 21 squared? $441. X squared would be a negative number. No solution. How about if y equals 7? If y equal is 7, then I'll get x squared to equal 49 minus 49, which is 0. So I only get one solution. I could look at the graph of that really quick. Graphically, I have a circle with a radius of 7, right? And this is a parabola starting at 0 right there. It opens down, but it's very, very wide, 1 over 128. So the graph looks something like this, in which it only crosses once. That could happen. Okay. Now, let's look at this problem. And let's use substitution. This is simpler. This is a line. Lines are normally easier to play with than, ellipses and parabolas, circles and ellipses, circles and parabolas. Here, I could simply substitute, since this is what y equal right there. The first equation would read x minus y equal negative 5, and y is what I'm substituting. I don't need that much space. And this will be x minus x squared minus 6x plus 1 equal to negative 5. Negative x squared minus 5x plus 1 equal negative 5. So if I get to factor, I need the leading term to be positive, so I move everything to the right. Okay, and this does factor, lucky for us, x minus x plus 6, x minus 1. So I'm getting x to be a negative 6r1. If x equal negative 6, what's the y? If x equal 1, and it's right there. If I put a negative 6 in there, that's 36 minus 36 minus 1. And if I put a 1, 1 minus 1 plus 6 is 6. That would be my solution. I did box all the other solutions, right? Oh, look at that. What do you know? And I'm going to highlight them too. since there's a lot of work and it's very hard to find. I only ended up with one solution. I ended up with two solutions. Now let me see. I have 3 more to go. It doesn't worth starting a new video over. It's going to be about 7-8 minutes. I'll just do it all in one. So the same deal here. This is already set up. Just throw that in there. That reads x minus 2, and in place of y, I'm going to have x squared plus 3x minus 4 equal a 1, and that's what I substituted. Now I'm looking at x minus 2x squared minus 6x plus 8 equal a 1, negative 2x squared minus 5x plus 8 equal to 1, and I'm getting 0 to equal 2x squared plus 5x minus 7, if I'm not mistaken. Let me make sure all of these numbers are right. 2, that's a 2, that's a 4, that's an 8, that's right, minus minus, so that's a minus 5. Move that over, add that, and subtract that. That's right, that works. And does this factor? Let's see how that works. Factors 7, yep, that does factor. How nice. 1 and 2, 1 and 7. If you subtract them, you get a 5 right there. Awesome. So 2x and a 7, x and a 1. I want a plus. So I want a plus and a minus. 2x squared plus 2 minus, yep. So x equal negative 7 halves, or a 1. And if x equals a 1, that's easy. It's right there. Put a 1 right there. That's 1 plus 3 is 4. Minus 4 is 0. Got it. And if I put negative 7 halves, that's not going to be as simple, but that's going to be my answer. And let's find out what that is. I'll get y to equal, if I put a negative 7 halves there, that will be 49 over 4 minus 3 times 21 over 2 minus 4. Not a big deal. I'm not afraid of fractions because I'm taking college algebra. If you multiply this by 2, that's 42. If you multiply this by 4, that's 16. And that's 49 minus 42 is a 7. 7 plus 16 is 23 over 4. There it is. A couple more. I could have stopped there and said, okay, this is it. I mean, they're redundant, but I think it will benefit you more to see more. If you had enough, that's fine. You could just watch those, and that's that. So here I have a circle and an ellipse. Okay, many things could happen. I could go over that graphically to glance, see how that looks. That's a circle. And the ellipse, if I divide by 225, I get x squared over 9 plus y squared over 25 equals 0. So I'm going to move 5 in the y and 3 in the x. Oh, it only has 2 intersections. Right? Again, graphically, this actually does benefit me. It's really quick. So I already know I have 2 solutions. We're going to do this algebraically, and what does that mean? That means we're going to solve for one of those. Let's solve for x squared equals 25 minus y squared. Substitute that in for this x. We're looking at 25 times x squared times 25 minus y squared. This is not bad to solve, and that's my substitution. And we have 625. Getting excited there. 625 minus 25y squared plus 9y squared equal 225. And we're having, oh, why is that? Okay, let me see. I'm getting 620, oh, that's working. I was worried. Minus 16y squared equal 225. If I swap those, I have 16y squared equal, if I take that minus 225, that would be 400. I'm getting y squared to equal 25, y equal plus or minus 5. Very good. If y equal 5, what do I get? And if y equal negative 5, what do I get? Well, if y equal 5, I get a 0. And if y equal negative 5, I get a 0. So there. In this case, it graphically was better, more efficient. In this case, because they happen to be right on the point, I could glance at that and graph this one as well, because, you know, I'm an expert on graphing. I'm talking about you, of course. I have a circle with a radius of 16. Assume, oh, why did I do that? Assume this is a circle with a radius of 16. And if I take the bottom and divide by 3600, I'll get x squared over 36 plus y squared over 100 equal 1. So I'm going to go 6 in the x left and right. Oh, 6 in the x left and right. Right? Yeah. And I'm going to go, this is 4 and negative 4. Right? So this is 6, this is negative 6. This is 10, this is negative. These are never going to cross. Right? Let's see how that plays out algebraically. Algebraically, I'm going to solve the top equation, say for x. I'm going to get x squared to equal 16 minus y squared, and substitute that right there. That would read 100 into 16 minus y squared. I thought that happened on the last problem. That's why I was pausing. I thought this has no solution. I didn't realize that this is going to give you a negative on the other side. So this is 1600 minus 100y squared plus 36y squared equal 3600. So this is negative 60. What is that? 64 y squared equal 3600. If I swap those, I will get, I really don't need that. That helped me know there's no solution. If I graphed it right, that is. If I actually swap those, I'll get negative 2000 equals 64y squared, or y squared equal negative 2000 divided by 64. That can't happen. So we have no solution. You have to write that. The answer is no solution. The answer is not just you crossing something out. So you're going to do numbers 5 through 33 every other odd. You're going to solve those algebraically. I suggest you graph if you want, but I want the algebraic work, and number 41. And that concludes this section.